2 chem, or not level 2 chem, level 3 chem. Can we, I made a mistake and I need to make sure I clarify it. So I said that this was a secondary amide when I should have said this is a primary amide. So primary amides have 2 hydrogens. It looks like an N attached to an H, attached to an H, attached to a C. So that is the primary. Now it's not focusing. And that should say amine, because I am not paying attention to what I'm doing. All right? If I had a secondary amide, which can come up, it would only have the 1 peak, and it'd be really shallow like that. And it would be a carbon with a nitrogen with another carbon and a hydrogen. So I was referencing the wrong component. I should have been referencing the number of carbons attached to the nitrogen. This nitrogen has 2 carbons. Okay? If you had a tertiary, which can happen, you just have a nitrogen with 3 carbons, but I'm not going to give you that on this assessment. If you are dealing with the amides, again, the double peak tells you have a primary one, so you should have a nitrogen attached to a carbon, double bonded oxygen, and then hydrogen, hydrogen like that. So again, you're referencing the nitrogen, and you're seeing how many carbons it has attached to it. Okay? If it was a secondary, you would have the nitrogen attached to 1 hydrogen, attached to a carbon, attached to another carbon, and one of those carbons would have the carbonyl. So this nitrogen has 2, 1, 2. All right? So the question that I gave you over here, I'm going to start giving you guys some of the notes, some of the answers, so you can start figuring it out. I'm just getting my colors. And I'll do orange for processing. I need a reference sheet too. Where's my reference sheet though? All right, so first step whenever we're tackling any spec questions, you should be looking at the IR spectra and figuring out what the functional group is, because there's no point in doing the rest of the question until you know what that is. Now, 2 different ways you guys can do that. First way is this bit here, which has your numbers. The other thing I'll let you guys take into the exam is a personalized student resource sheet. I've assumed you guys would want the pictures of each functional group to help you identify them. If you don't, that's fine, but I will let you bring in 1-page double-sided into the internal. I could technically make the assessment open book. There's no requirement that says it has to be closed book, but the problem is I don't want you guys to get lost in your sea of notes. That's why I want you guys to just bring in 1-page double-sided. Okay? So first step to do is, Lucy, I'm kind of worried, and Alyssa, you're not listening to me, and this is then how you fall behind in chemistry. So I would use this sheet here to help you kind of identify what this guy is over here. So you're basically trying to match them like you are in primary school, taking cards and trying to match them together. So I'm trying to figure out which one this one looks like. I notice that it has this peak that's just above 3,000. And I know when I look at this reference sheet that alcohols have that, and also amines, amides, where the NH is, also have that as well. Yeah? Did I have it right the first way around? Oh my God, I did. Did I? I have to look that up now. I'm kind of second guessing myself again with the amides, amine things. Anyway, don't worry about it. So you see how it also has here that if you were having that nitrogen hydrogen peak, it would be at 3,300, 3,500. So that both are in the same ballpark region, so I need to understand what the 2 look like. So when I look at it, that's what the alcohol looks like, one giant trough. This one here is my amine, and you see how you have the double peak here, which tells me there's 2 hydrogens there. It's very short. And then the third option is I have well, I have this one over here, which is carboxylic acid, so that's the OH again, but you see how it's crashing in to the CH, this bit here? And then this is my last option. Double peak doesn't crash into the CH. So these are my 4 choices. I look over here and I go, what does that look like? The amide. So that's my first bit of information that I've identified, is that I have an amide. I'll do the Achieve Merit Excellence color code again. So A, M level stuff, E level stuff, just so you guys are aware. So the first thing I've done is identified the amide. Be mindful that we do need to justify why. I will hold off in justifying why because I want to give you guys a chance to answer the question. All right, so that's my first bit of information. When you are drawing an amide, just as a reminder, an amide is a C double bond O NH2. And then there's some R group that we don't know. So that's my big question mark. What is attached to that molecule? Okay? Skip the CMMR, go down to the mass spec, and the thing that you're going to try to figure out here is what is the mass of my ion, because it tells me how many carbons I have. When we are looking for the molecular ion, you're looking for the rightmost ion, so the biggest mass, not the biggest height. By chance, this guy's biggest height is also the molecular ion. So the base peak and the molecular ion are the same peak. Not always the case, happens to be in this case. So be mindful of things like background noise. If something was the molecular ion and it was that tiny, I would label it for you. This one is not the molecular ion. I have not labeled it for you, so it's this guy over here.
What would it look like if you did label it?
I would have a point and I would just go like that. If it was. But it's not, so. All right, that's my molecular ion, which is 59. I can see that over here, that's 60 minus 1, 59. So that tells me that the mass of the ion is 59. So we're gonna have to use the atomic masses to start figuring out then what is my molecule. So this is now getting into the merit territory, trying to figure out the molecule. So things to keep in mind when I'm trying to do that. I am taking the mass of each one of these elements and I am adding them together. So if I look at the back here, I don't give you a periodic table because you don't need the whole periodic table. You just need a few of the ions. Sorry, a few of the atoms. So oxygen, for example, is right here. Oxygen has a mass of 16. So that's the protons and the neutrons. So I'd have 16. And then I would need to add to that 16 my carbon, which is 12. I would need to add my nitrogen, which is 14. And I would need to add my 2 hydrogens. Hydrogen is 1. Since I have 2, I times it by 2, so I'm adding 2. So add these numbers together, and then you're going to do the magic add 14 until you are 1 away. The reason why we add 14 is because, and I'm just going to switch to my general notes. I'm doing an orange. Whenever you guys add an organic molecule, whenever you guys add a carbon to an organic molecule, it is C with 2 hydrogens, and then I don't know what's on either side, right? So this is how I add a carbon. So whenever I add a carbon, I need to add 2 hydrogens with that, so that way it has got all its bonds. It's a link in the chain. So the reason why I'm adding 14 is because the mass of this component is 14. Carbon is 12, and then I have 2 hydrogens, each of which are 1. So 12 plus 2 is 14. So that's why I say add 14 until you are 1 away from the mass. Okay?
When you say 1 away from the mass, you mean like 1 second like digital from this?
Yeah. So basically
Above or below?
above. Sorry, below. So 58. So basically add it until you get to 58. So figure out what this number is, add 14. If it's not 58, keep adding another 14 until you reach 58. Okay? Give that a go. I'll give you another 5 or so minutes to try that out, and then I'll go over the answer. All right. Level 3 Chem, I'm going to go over the answer now, just so you guys can see a worked example, and then I'll give you another question. I want you guys to pay attention because I'm very mindful that the videos I've put on for the last couple of lessons have not been great. So I'm trying to teach this a lot better. So I suggest you listen to me now and stop me if you don't understand it. So, and I know some of you guys are working on bio. You need to stop working on bio. You're working on bio. All right. So let me just walk you through what I'm looking for the assessment. And again, I'm going to keep to the color code A, M, and E. A is in red, merit is in blue, excellence is in green. Something else to keep in mind is, I'm going to use orange just to kind of show my thought process. So basically it's stuff that I'm writing down that you would not need to write down in the assessment, but just showing you how my brain's working. All right. So this is actually a really easy assessment to get and achieved on. Let me quickly run you through what you need to do so that way you guys can be like, oh yeah, this is a piece of cake. I don't have to worry too much. So in red, all I need you guys to do is identify features of the different spectra and tell me what they tell you. You do not need to figure out the molecule for the achieved. That is the great news. If you're really, really struggling, don't worry, you're probably going to pass. All right, so like I was saying, I need you to first identify what this is from the spectra. Remember, I will let you bring in your personal resource sheet, which has the images on here, and you're allowed to annotate it however you want. You can also write on the back of the piece of paper as well if you want some other things to help you remember what you need to remember for this task. But we discussed previously that it was an amide. What I also need you guys to do is I need you to annotate or write down how you know it's an amide. You can't just write amide and be done. I need to know what you're talking about. So identifying this here, that we have something that is roughly between 3,500, oops, wrong unit, to 3,000. And that we recognize that this is an NH2 from that information. So we have a nitrogen with 2 hydrogens. I have to look up my primary, secondary, tertiary. While you guys do that, I'll look that up. It's my brain. Oh yeah, I was right the second time. Yep. Sorry, let me just show it on the board. Okay. So primary has the 2 hydrogens, so I was right the second time. Can't always trust my brain sometimes. All right. So this is a primary amide. Sorry, a primary amide. The next thing is, why do I know it's an amide? And that's because I see that there's a peak here at 1700. And that is my C double bond O. So the combination of these 2 bits of information tell me amide. And in fact, for the achieved, I don't need you guys to label it that's an amide. You can just label it like this, and that's enough. Okay? Keep going. All right, next thing I need for the achieved is for you to count how many lines there are here, and then write that's the number of carbon environments. So I have how many lines here? 2. So I have 2 carbon environments. Last thing I need you to do is identify the molecular ion or the base peak. So molecular ion, this one's actually also the base peak, which is at also 59, which makes sense considering how small it is as a molecule. So just so you guys are aware, base peak is talking about the highest one. Basically, it's my reference to what is 100%. This is my most common fragment. The molecular ion is going to be the one that's to the most to the right. If it's not clear, I will label it. So just be mindful that this here is background noise. Now I can't spell. If it was the molecular ion, it would be labeled. Okay? We good so far? All right. So I just need you to label either the base peak or the molecular ion. You can label both. That's a good idea, just so that way you cover your bases. That's all I need for the achieved. You have passed. 3 credits. That's it. So figure out the functional group, count the number of peaks, and then identify the tallest peak or the rightmost peak, and you are done. See, easy peasy. The hard part, and this is what I have an issue with a lot of chemistry standards. It's really easy to get a lot of the achieved, and then the merit is a huge jump, and then from merit to excellence, it's a very small jump. The chemistry standards are very poorly designed that way. So the bad news is going from achieved to merit is a huge jump, but then once you get merit, you might as well get excellence because it's not too much extra to ask for. All right, for the merit, you need to figure out what the molecule is. So that process is going to involve figuring out what you have as your functional group, doing the math to add this up. Let me grab my phone so I have a calculator, because you know I can't do mental math. So we have 16 plus 12 plus 14 plus 2. Did I do that right? 16, 12, yeah, 44. Fun fact, I have given you guys a shortcut over here. There are some common fragments and their sizes. And you can see here that I have given you 44. That is an amide fragment. And in fact, when you guys look, there should be a big peak at 44, which you see here, 45, 44. So that double checks it. All right. Next thing we are then doing is we're trying to figure out how many carbons there are. So we're playing the game of add 14 until I am 1 away. The reason why we're waiting until we are 1 away is because when you have the end carbon, you're going to add 1 more hydrogen, and thus it's 1 away. So I have 44, I add 14, I'm at 58. I only have 2 carbons here. All right. I see the smile on Angela's face. She's like, this makes sense now. I'm glad. All right. So what this tells me is I have a 2-carbon molecule that is an amide. So all I have to do is C double bond O, NH2, C, and then if you want, you can draw it extended. You don't need to. That's my molecule. You don't have to name it in this assessment. It's good practice to name things because you need to do that in the organic external. This is the answer. This is my molecule. If you can figure out what molecule this is, you have now gotten yourself a merit. This was a really easy molecule, though. I'm going to give you more challenging ones for the assessment because for the excellence, you need to be able to tell me what it's not. So merit is figure out the molecule. It is. Well, this is the build-up from ion identification. So ion identification was 2.2. This is 2.3. All right? So figure out the molecule is the merit, and then the excellence for this one is figure out what it is not. So further justify your answer by showing what it's not. Okay. There is one more thing that you need to add for excellence, and that is showing integration of spectra. So basically, you want to show that the spectra are complementing each other in the identification process. One of the ways you can do that is by justifying what you see in the CMMR. So the CMMR you can also use to figure out carbon environment. So you see how you have approximate values on the chemical shifts in the C13 MMR spectra. So this is another way to identify functional groups. I will explain how that works probably in tomorrow's lesson, but I'll see how you guys go. So for example, I want to prove that this peak here is a amide. So I would look to see C double bond O in carboxylic acids acid chlorides, amides, and esters. I have an amide, and it says that it should be around 160 to 185. So I look here. See? 160, 185. It's in that ballpark range. So I can use this to confirm. So we have a peak at 180 ppm confirms amide presence. So that's showing integration now. The other way that you can integrate it in is by the mass of the ion. So something that is unique to nitrogen, because of its number being 14, it's always going to give you an odd number. So if your molecular ion is an odd number, you have nitrogen present. So you see how I'm integrating it in together to explain what it's not. Sorry, what it is. The other thing is figuring out what it's not. So let me show you an example of figuring out what it's not. So Xander came up with 3 different options for this answer, I think, but only one of them was correct. All right, one of the other answers he came up with was it could have been an amine with an alcohol. Was it like an alcohol attached? You have to have the double bond as well.
Yeah, the double bond carbon.
Ah, like that. So this was this disgusting molecule he discovered. All right? This does work mathematically because when we add up these numbers here, it does add to 59. Okay? So this is an example of a structural isomer. And that's why I had you guys do so much practice with structural isomers. But this is not the right answer. There's multiple reasons why this is not the right answer. The first reason is that you're missing the carbonyl. Is missing, which is shown on the IR. Yeah? The other thing is that the IR did not have an OH. Yeah? And the last reason is that this here, the amine, was too deep. Because remember, when you guys are looking at the amines, it's much shorter. All right, so that's why that's not the correct answer. So that's what I'm looking for the excellence. Excellence is eliminating one of the isomers and why. So this is a potential isomer. There's another way to do that, and that's with the carbon environments. But in this case, there's only one type of carbon environment because it's only 2 carbons length. So there's no way you could have had a 1 carbon peak. All right. I will give you question number 4. It's worth doing as homework. I'm going to say that is going to be your homework. And we'll talk about the answer to that one tomorrow. Okay? Caleb. You're done? Okay.